Let's review these forces one more time. Gravity, so this is really great, right? 7 things tell us everything we need to know about the world. 3 fundamental units and 4 forces, okay? Gravity is one. We know gravity. Gravity just attracts everything, okay? Gravity is purely attractive. There have been simple experiments where they've taken up onto the space station, which is microgravity, so you ignore Earth's gravity, and they've taken, items. I think it was like grains of rice or something, and they put them in a bag, and you can watch them all kind of float around in the bag, bounce off of things, and then they all begin to clump together. Gravity is an attractive force. Weak nuclear force, responsible for radioactivity in the nuclei of atoms. We got that. Electromagnetism, electrical phenomenon, such as electricity. Magnetic phenomena, such as magnets. Okay, and all electromagnetic waves are all parts of electromagnetism. And lastly, the strong force, which holds protons and neutrons within the nucleus of their respective atoms. Think about it like this. What was the charge? Tyson said the charge of a proton. What was the charge of a proton? Was it positive or negative? Positive. Pro means positive, okay? So it's positive, and we just say the charge of a proton is +1. It's a positive charge, and we say it has a value of 1, okay? 2 protons have charges that are positive, okay? What do we know from lessons on electricity about opposite and like charges? Are like charges, 2 positive charges, do they attract each other or repel each other? Repel, right? You can do this with magnets. Take the north and south pole, take the north poles of 2 magnets and point them towards each other, and what do? They push away from each other, right? Opposite charges attract and like charges repel. So then you ask yourself, well, what the hell are all those protons doing in the nucleus of an atom stuck together when they all have positive charge? Okay? From what I just said, shouldn't all those protons repel each other, and shouldn't all atoms just fall apart? Okay? Well, that's true. But you have to think of protons, which have the positive charge and are repulsive, you have to think of protons as having a layer of sticky glue on them. Okay? So if something has glue on it, and let's say a magnet has glue on it, right? And I have this magnet, so the magnet is going to be repelled from the whiteboard. Okay? So I'm holding a magnet, it's being repelled away from the whiteboard because I got it flipped the wrong direction, right? And the magnets, I got to push the magnet towards the whiteboard, and it's pushing back, and I push harder, and harder, and it's still pushing back even harder, and the closer I get to the whiteboard, the harder that magnet is pushing back away from the board, right? But remember, I coated the magnet in glue, okay? If I get the magnet close enough to the board for that glue to stick the magnet to the board, I will have effectively overridden the repulsive force of that magnet, and the magnet will stick to the whiteboard, not because of the attractive or repulsive forces, it's actually being pushed away from the whiteboard, but the sticky glue is holding it to the whiteboard, okay? The strong nuclear force is a lot like that. Protons out in space, if they get close, will just repel each other, push away, okay? But you take protons and put them in the middle of a sun and heat them up and make them move around extremely fast, as he was talking about in the video, eventually those protons will be slammed together with so much force that the sticky glue on their surface, they don't actually have sticky glue, but for the analogy, the sticky glue on their surface will lock them together, okay? Fusing them together. This is called nuclear fusion, and the strong nuclear force is what's responsible for nuclear fusion. Once you can slam protons hard enough together, they will stick together instead of repelling each other, okay? This is also why, when you have radioactive decay, the protons are shot away from the atom in radioactivity. You guys remember the cloud chamber video I showed you last class with the particles flying everywhere? Well, if you can break the strong force, then now it's broken, and now the repulsive force takes over, and the proton is just shot away because of the repulsion. Okay, so the strong force, responsible for holding protons and neutrons in the nucleus of atoms. Okay. Let's talk about energy. Let me make a break in the video here.